I think you can see my presentation. So at the University of Queensland, we did diagnostic testing with our incoming students for the best part of 20 odd years, and then it stopped. And then we decided to restart it in 2008, and that was a paper-based test in the first lecture in our two different maths subjects, depending on what the students did at school. They either did one maths subject or they did two. That paper-based test was really good, but obviously in the first lecture of semester with 1,000+ students, it takes a long time to mark, and there's a cost associated with that. And so the teaching staff didn't get the information for the best part of the week. So in 2009, we moved it online with our GetSet system. The interesting thing about GetSet is that it is just a shell. It wasn't built specifically for the maths question. It was designed by the team so that any academic could put in their own questions. And the really unique thing about GetSet was the feedback matrix. We just didn't want students to have a go at some questions and then we go, thanks very much, and we might use that data in our lectures. We wanted to feed back to the students what their results actually meant for them. And so we put in the feedback matrix, which gave the students individualised subject selection advice. The engineers have a lot of electives that they can choose, and they got some advice about which ones they should choose in, say, first semester, or perhaps move it to second semester based on what mathematical understanding they had. We didn't want to go in with the deficit model and say, look, you can't remember any of this from high school. We're getting the students 4 or 5 months after they finished high school. Some of the topics they hadn't studied for the best part of a year and a half. We wanted to know what they could do on the spot, either in their first lecture or in the week before lectures started. And so we moved from a paper-based diagnostic test to an online diagnostic test. And then with the online version, staff could have those results straight away. They could address some misconceptions or some interesting results in the first week of the lectures, and then perhaps modify what they taught if they needed to. And we also used it to identify some at-risk students. If people did particularly poorly on the maths questions, then our academic advisors could contact the students and say, hey, look, did you have a good go at it, or are you really struggling? So there are a lot of benefits with our GetSet system. Here's an example of the feedback matrix, and this was very different to what was in existence back in 2009. And so across the top, you have a bunch of subjects that first-year students can do in engineering. The first 3 are mathematics, and then they have their electrical engineering. They've got some materials, they've got chemistry, they've got physics, they've got computer science, and then some other engineering subjects, thermodynamics, mechanics, etc. How to interpret this feedback matrix? Well, the tick represents the fact that you got the question correct, and that particular concept is relevant to that course. And so if you just ignore the first 3 columns, the first 3 math subjects, but let's have a look at the 4th column, which is Eng 1010. This fictional student, they could add 2 numerical fractions, they could add 2 algebraic fractions, they could solve an equation, which is a linear equation, and they could expand a factorized quadratic. They could do those 4 questions, and those 4 topics were important for Eng 1010, which from memory was thermodynamics. They got all the other questions wrong, but because they are crosses, those topics are relevant to Eng 1010. So with a student coming up with this feedback matrix, they would go to the academic advisor and say, look, I got all these questions wrong. Should I really be doing Eng 1010 in first semester? And a good academic advisor would be saying, no, you need to do one of your maths subjects in first semester, and then you can have a crack at Eng 1010 in second semester, because they got all of those questions wrong, but those topics were relevant to Eng 1010. You can see in Chem 1020, the middle column, I think it is, there are dashes everywhere, which means that none of those maths questions, those concepts, were relative to that chemistry subject. Likewise, computer science, those two subjects on the very right-hand side. What we found with this feedback matrix is students were pushing a particular subject, and it was actually thermodynamics, to second semester because they hadn't done the required mathematical content before they had a go at that subject. And we had failure rates that were quite high in thermodynamics in first semester before we implemented GetSet of about 40 or 50%. Once we implemented GetSet, the students were going, oh, hang on, I shouldn't be doing thermodynamics in first semester. I should be doing it in second semester. And lo and behold, the failure rate for that subject dropped to about 10%. So there was a real outcome from implementing GetSet. The next page of the report that the students get as soon as they've finished the questions was this one. We put in some recommended resources to go and have a look. And so the McMaster University Maths Review Manual from Canada was one that we really liked. And then also Maths Centre from Loughborough in the UK. And there were also chemistry questions and physics questions as well, but we're just looking at the maths ones today. That was for the engineering students. And so we did this in engineering from 2009 onwards. In 2015, we implemented it across our Bachelor of Science, so a different faculty. And we got a bunch of the academics, the lecturers who teach into the Bachelor of Science to get together and say, look, what do you want to know from the students? Once the science students had a go at GetSet, and we'll show you some of their maths questions in a minute, we asked them how they felt about the whole process and what they thought their results meant to them. And so this was from our very first cohort of the students who did GetSet for science. And the results were quite pleasing. You can see some of the higher responses there. Yeah, I've forgotten a bit, and it's made me realise that I need to go back and refresh some topics. Let me know what I need to do at uni, what's expected, what is some of the assumed knowledge. And then if we skip down to the fourth bottom one, I forgot a lot of what I knew during the holidays. This was back in the days when we didn't have external exams in Queensland. It was all school-based assessment. There was not a big final exam at the end of grade 12. Things have changed and we now do have a big exam, but we're still not seeing the students for the best part of 4 months after they've done those exams. So that was some of the feedback that we got from students. When we first designed the maths questions, and there was a team of us helping the engineers design their maths questions, the engineers really wanted procedural understanding. Could a student do the product rule? Could they do the chain rule? Could they solve a quadratic? It was very procedural. There was very little conceptual understanding there. But the scientists were different. They wanted to know what the students could actually understand, not just what could they do. Before we get to some of those conceptual understanding questions, this maths question, it was question 4 in the science quiz. It was actually the very first question in the paper-based test in 2008. Add these two algebraic fractions, which we hope that a student having done 2 years of maths at high school, perhaps they've done 2 lots of subjects of maths at school, could do this pretty well. Well, when we did it the very first lecture of semester, fewer than 50% of students in the cohort that had done double maths at school got this question correct. It wasn't multiple choice in the paper-based one. They actually had to put down an answer, but fewer than 50% could do it. Of the group that had just done 1 maths at school, only a quarter of those students could do this. Those responses really shocked the academics. And so what we wondered was, okay, are they really having trouble with algebraic fractions, or are they just a bit rusty? And so what we did the next year was put in 2/3 plus 3/4. We gave them a numerical fractions question. And thankfully, that seemed to jog their brains into how to do algebraic fractions, because the results went from less than 50% to 95% of students could do this question once we put in the numerical fractions one. So that was question 4 from science. And then we head into Question 9, which was more of a sort of a conceptual understanding. There wasn't a question that students actually had to do. It wasn't an equation to solve. We wanted them to think. And those of you who have taught, say, Calculus 1 or first year calculus, it's that idea of limits and, you know, what happens when you get 0 over 0 or infinity over infinity, that kind of concept. Students really struggled with question 9. A lot of the answers were it would be 0 or can't remember how to do it was a popular answer. All of the questions had those last two options, can't remember how to do it and never seen before. The never seen before one was largely for our international students and our interstate students. At the time, we didn't have a national curriculum in Australia. We sort of do now, but each state can still do their own thing. We didn't want to force the students into giving an answer. We were happy for them to say, I'm a bit rusty on this. And that was actually quite interesting because of those derivative topics that students saw towards the end of their senior schooling, they were really rusty on solving for critical points, product rule, chain rule, quotient rule. And so that told us that students didn't have a great grasp of those topics. And so we made a point to revise those concepts in class. Question 7. There was a lot of debate about question 7, particularly the answers that were longer than 4.5 hours. And so if you can't read the question, I'll just read it out quickly. It takes 2 people 4.5 hours to paint a fence. If a friend joins them, and assuming they work at the same rate, how long will it take the 3 of them to paint a fence of the same size? When we were discussing the answers for this, one of my bosses, the Associate Dean Academic, so sort of the top teaching and learning person in the faculty, said, get rid of all of those answers that are longer than 4.5 hours. No student in their right mind would say it's going to take longer. And I said, look, can you please just humour me? Let me know. Give me a chance at this question for 1 semester. And if none of the students choose a time that's longer than 4.5, then I'll change the answers. Because I knew, being a high school teacher by trade, is that students would go, oh, okay, well, 2 people, 4.5 hours. That means 1 person, 2.25 hours. So 3 people will be 6.75 hours. And so they are carefully chosen distractors. There are algebraic ways of getting 9 hours and also 13.5 hours. And we ran it, and lo and behold, 25% of students said that it would take 3 people longer than it would 2 people to paint a fence. And so this was really eye-opening for some of my colleagues, particularly in the sciences, not in the maths. We also analysed all the responses based on what discipline they were in science, so physics students, maths students, biomedical science students. The group of students that struggled the most with this question were the biomedical science students. And that was particularly scary because most of those students want to go on and do medicine and become doctors, and they can't do inverse proportion questions. Another conceptual question in question 18, it is about derivatives, but we've said the derivative is negative everywhere on an interval from x equals 4 to 5. Where is the maximum value? This isn't a standard question in high school calculus. It's not, here's an equation, find the derivative, set it equal to 0, check that it's a maximum or a minimum. Very different. And a lot of the students said there is no maximum as the popular answer. And then question 19, again, was a conceptual understanding question. If the function is always positive, what must be true about its derivative? And there are a whole range of answers with that. And so with the science GetSet, we're interested in what the students understood as opposed to the engineers who just really wanted to know, can they do a particular procedure? Things that we have talked about over the years, and I guess these are things that people are doing when they design their diagnostic test, regardless of whether you're using GetSet or not, is, well, what do you actually want to get from the students? Is it a bunch of procedural understanding? Is it more conceptual? Or is it a combination of both? When are you going to do the test? This test used to go out with the hard copy of the enrolment book that went to the students about a month before they came to us. They could sit around with their parents and go, okay, look, I'm supposed to do this test. I'm going to have a go at it. And there was lots of discussion and a really high participation rate. Since we have moved to an online welcome guide, everything sent via email, the participation rates are really plummeted. And so we're in the process of trying to bump that participation rate back up. And a very important thing, what are we going to do with all this information, all this data that we get from the test? Some academics make an effort in their first lecture or two to talk about some of the key errors or the key issues. There's no point just collecting all this data and then doing nothing with it. As I said, GetSet is just a shell. You can use it throughout the semester, at the end of the semester. You could do it at the end of their degree. It was just a system that allowed people to relatively easily get some information from their students. Nearly finished. As I said, we started in 2009 with our online version with some funding from the university. We then got some Australian government funding in 2013 that involved 4 other universities and involved some other engineering concepts. And then the science version, I've showed you a few questions, that was another government grant. We're currently revising the questions. We've been using the same questions for the last 10 years. We've changed systems here in Queensland. We've had the last 5 years of external exams. And so this year we're going to revise the questions and talk to our colleagues again and see what do they really want to know from their students. A bunch of other universities have taken up GetSet and implemented it in their own universities. Melbourne, Sydney, La Trobe, not just mathematics, but chemistry and a few other disciplines. And I see Ken from University of Sydney is talking after the break, and I'm keen to know if Ken has been using the system. There's been a bunch of publications on GetSet. There is one from the early days. That's it for me, but if you'd like some more information or a copy of the questions, please feel free to contact me via email or type your email address in the chat and I can send it off to you. But thanks very much for listening.